Welcome to Privacy Now, your go-to podcast for privacy, crypto, and AI. Each episode, we dive into the latest advancements, explore cutting-edge innovations, and bring you insights from experts shaping the future of Web3 and AI. From crypto degenerates to the ones in it for the tech, Privacy Now has got you covered.
Hey everyone, welcome back to the Privacy Now podcast. As always, I'm Mihnea, your host, and today we have a fascinating guest on the show. Especially if you've been following the intersection of AI and blockchain, you might have heard of Yannick Myson. He's the founder and CEO of Swarm Network. This is a new platform using swarms of AI agents to tackle the truth in what I would say is a decentralized way. And Yannick's background is fascinating. He has a really nice tech journey that spans from early Bitcoin mining to creating AI networks for the lithium, and now building open source swarms that challenge misinformation at scale. So yeah, welcome, Yannick.
Thank you. Very happy to be here, man.
And I hope I got everything right.
Yes, you did.
I did some research before the show, but
that was actually a better introduction than I usually get. So
okay.
Good on you.
my pleasure. So Yannick, today we'll talk about AI agents, of course, maybe privacy, sparkling a bit of privacy into the discussion. But I always like to start with the basics. So maybe take us back to the beginning. How did you get involved in the world of crypto, and afterwards in the world of AI? Or I don't know how it was. Which was the first? Which was the chicken and which was the egg for you?
Sure. Yeah, I mean, like I don't consider myself to be fully educated and a true expert in anything yet. I think like the process of me constantly discovering new depths into like blockchain and AI is like a never-ending journey. Like every day I read something or I'm researching something and I'm like, like continuously dragged down deeper into the rabbit hole. Especially on the technical aspect, because originally I'm not really a technical person and I'm just starting to, I'm just on that journey of being a tech founder, right? And it's a very different thing. And the learning curve is quite steep, but I'm managing pretty well. I was lucky because I was introduced to Bitcoin when I was in college, when I was in University of Applied Sciences in Groningen in Holland. We're not really going to school because I was running, I had my first kind of like online business back then, which I started actually right before I went into university. But I had this really crazy like group of friends, man. Like we had so much fun. The majority of the time we were actually partying, and then when we're not partying, we're just like scheming and like thinking about the future and like imagining what we do and where we're gonna be in like 10, 20 years from now. And we called ourselves like the chilling palace young gods because the world of opportunity was before us. And I think there was like a group of 20 guys, and I think every single one of us was like, like we're going to be millionaires in the future. We're going to have our own businesses and so on. Although not many people, made it to that level yet, but I'm sure a lot of them will. But through that group of friends, I got introduced to a guy, and was a strange guy, but he introduced us to Bitcoin mining. So like, before we started the podcast, we were talking about the hardware, right? Yeah. People tend to forget that the whole infrastructure is literally built on hardware. And he got us into it back then. It was a lot of fun discovering that whole scene. But the problem with me was that I was not really capable of understanding, I suppose, the societal impact that such a technology could have in the long run. And it was still so nascent, and it was still so fragile, and it was still so young. And there was not so much of like a community around it that was really able to pull me in and interact. That there were not that many people that I was able to interact with regarding this technology, which was Bitcoin, except for this crazy friend, like the kind of friend that would come to your house at like 4 a.m. in the morning with some weird ass CIA reports on mind reading and all. Like we was like really out there, man. Like holy cow. But yeah, so I kind of lost interest along the way. Did a bunch of like other businesses. Like if you look at my LinkedIn, you'll see a whole slate of businesses. I dropped out of dropped out of the University of Applied Science because I just felt like, everything that they were teaching me there was kind of like something that I just could just literally go to YouTube, type in like what I was, interested in, and it was always anyways related to business. I was studying international business and management, by the way. And I would just like consume it, I would learn it, I would know it, and I'd go to school, and then they try and they try to teach me like one thing like in a volume like this, which I could just learn in literally like 15 minutes through a YouTube video, and then actually apply it in something realistic, which was a real business, right? So I went on and I did many things in business, many like unsuccessful things too. But long story short, I eventually went to Southeast Asia because I couldn't find my spin in Europe, because I just felt that the system there was not really supportive of entrepreneurial minded people like myself. I feel that that's still the case. There's so much regulations, there's so many rules, which makes it a very stagnant and unsupportive environment. Like if you have like a really great idea and you share that with your environment, your local community, people will be like, yeah, that's never going to work, like you're just dreaming, you should go and get a normal job, like I always.
I
Yeah,
thought it was just a Romanian thing, but apparently it's a Dutch thing as well.
It's the Dutch thing too, man, and it's a shame really, because there's like around me there were so many bright kids, man. Like really, I think that was also like the energy and the vibe that I had that attracted a bunch of people around me. But really, like we didn't feel like we couldn't dream. We actually dreamt. We had very high aspirations, but the environment was just not properly aligned with our aspirations, and it was just like, you want to go right, but the only way is left. Like it's really a shame, because that's actually one of the majority, the main reasons, not the majority, but what I wanted to say is like the majority of my friends, the main reason why I think they eventually didn't live up to the aspirations that they set, like when we were like the chilling palace young gods, it's so funny, is because they weren't able to detach themselves from the environment that they were in, and really like like kind of like the social shackles that the society tries to put upon you, but then also the shackles of your friends and your close, your environment, your schools, the institutions and so on, like they hold you down. So I only saw one way out, which was like, get the hell out. Like I was like, okay, I need to distance myself because my box is so small. I need to take myself outside of the box, and I need to make my box much bigger. So I went to Southeast Asia, did a bunch of business there, a lot of really crazy stuff. I actually, was also doing music festivals, very large music festivals.
Oh, nice.
Yeah. And I got to work with some of the largest companies in the world. We were running an agency, which was kind of like a hybrid advertising slash culture slash artist agency. So I got to work with like Coca-Cola, Monster Energy, Pepsi, Heineken. I was actually briefly involved with a blockchain project for Heineken in Southeast Asia that never left, like its base. It never went somewhere, but it was really interesting because it kind of like got me into a really different world. And in that world in Southeast Asia, like people were encouraging you to do something, and there's no constraints, there's not that much regulation. So there, naturally we were very free to do whatever we wanted. So eventually I got back in touch with crypto really through like realizing that there was much more to it than just the financial side of things. Because when Ethereum came around, I started to understand that there was much more possible, but it was not really possible yet. It was still a vision, it was still a dream, right? It was still this, okay, we can probably make smart contracts work very well, but that process took a while. But then eventually when, there was like a bunch of hype around NFTs and much more programmability possible on smart contract level, I started to gain interest in it and started to test this out. Collaborated with a bunch of artists, sold my first NFT for 1 Ethereum, and I was like, whoa, okay, so like there's real value here, right? Like somebody is willing to give me like 1 Ethereum for like ownership of this thing. So now I was really into it. And then eventually I just looked at myself and I was like, yo, am I really going to sit here and be busy all the time with like non-Web3 stuff when I know that Web3 is the future? And I was like, no, I need to, make moves here. And then one thing led to another thing. Eventually I ended up with Delicium, and I stayed with Delicium for a while. Like Delicium was a really good opportunity. And actually some of our co-founders and some of our team was also ex-Delicium team, co-founding team. And what we were doing was very much AI agent based and AI agent focused, but even pre ChatGPT, like reinforcement learning is where our company originally started. And through that, I started to develop more of the understanding of the intersection between like blockchain technology and AI, but specifically AI agents. And that led me to actually founding Swarm Network today.
Okay, I did want to. I'm glad you mentioned the Elysium, because I did want to ask if you took away any lessons from it, because I know you helped build their AI agent infrastructure, right?
Yeah.
So what lessons did you take away from the Elysium and implement into Swarm?
Yeah, I think one of the major lessons is probably like, I mean, it's a culmination of different lessons, but through the journey there, I really was able to distinguish the difference between the Web3 world and the Web2 world in terms of what really matters and what drives adoption and what drives change, and how do you take care of all of your stakeholders, for example. So, like stakeholder management and stakeholder value in Web2 and Web3 is very different. And I think that a lot of VCs, investors, even just retail, like degens, they have PTSD from last cycle, especially towards the end of last cycle and early this cycle, because there was so much, new things out there. Everybody's throwing money at everything, but then actually there's no real return on investment. So one of the things is definitely that I learned how to take care of your community, your stakeholders, and we actually did the things that we had to do in order to be able to bring our project into like the top 200 and like reach this $2.7 billion FDV, while at the same time also working on the tech in a very diligent, non-grifting way. So I really got to see like what is the difference between like a proper project and an improper project through that experience, because we were dealing with some other people and some projects around us which were, like just like kind of like a facade of greatness, but then if you look behind the scenes, there's actually nothing going on. So I really managed to like figure out the mix, like a little bit of this, a little bit of that, like, and where should our priorities essentially really be? Because it's so different from Web2, man. It's really, really different.
I know. I speak to a lot of founders and all sorts of different jobs in crypto, and it has nothing to do with Web2. Like the whole business model, marketing, community, everything is different. So you need totally innovative approaches, and you need to think out of the box for sure. But I know people still compare this whole space to the .com era, right? But I don't think it's anything similar, because the number of visionaries you have in Web3 I think surpass any industry at the moment.
Yeah, that's true. And it's really a different game, like with Web3, because you don't have the whole world in your pocket yet. What I mean is that like you still need to be a catalyst, or there still has to be an auto catalyst for widespread adoption. But at the
Exactly.
same time, you can also not build too narrowly, because if you build too narrowly, if you build too specific, like if you, let's say, like, yeah, if you build too specific in any direction, then it's also not really going to work out on the long run, because like we always run into this issue, right? It's like, I hear a lot of people say, for example, I want to build like the Uber of crypto, but the counter argument to that is like, yeah, but there's Uber already. Like nobody's needs
Yeah.
the crypto version of Uber. Like that's not how the game works. How the game works is you need to be able to live 10, 15, 20, 25, maybe even 30 years in the future. You need to be able to foresee like what kind of like seismic shifts are going to take place. How is the TradFi going to move to blockchain? And then how are you going to position yourself as a almost like an infrastructure,
Exactly.
like a critical piece of the infrastructure. But then the problem with that is like, that's not enough, because still your metrics right now also count, right? So you still need users right now. You still need to prove yourself. You still need to show what you can build, and how is it going to be effective, and how is it going to matter in the future. So it's always this dilemma between these things, and it's really hard to manage that. And people really don't get it right. Like most of the projects I think that are being built, even by some of my friends, I think they don't get that equation. I don't think they don't understand that on a fundamental level. They either get the latter right or the other thing
Yeah.
right, but not the combination of both.
I agree, and I've heard this discussion a lot of times. Like, yeah, let's build a Uber on chain. Let's healthcare on chain. Of course, healthcare would benefit from blockchain a lot, but it's hard because it's hard to get the traditional industry to implement these technologies and understand the benefits. And so, yeah,
Yeah,
infrastructure is important. You need to be that
yeah,
piece of a puzzle that
yeah.
leads to wide adoption.
Because
Sorry.
it's
Yeah,
it's
yeah, yeah.
it's hard.
Sorry.
Yeah, and I understand why it's hard to, because it's like, okay, explain the benefit and explain the incentive. Okay, maybe those two are not that hard, but then get people to care about it. That's probably the hardest part,
Yeah,
right? Like, okay, you get the benefit, right, for the end user. Like we're actually struggling with this too. I'll tell you about it later. And then you get the incentives really right. Okay, that's a really good equation, right? That's okay. Benefits for users and then incentives for anybody involved, stakeholders, right? But then get them to care about it, right? You might have those two. You might have like a really nice technical solution. It's sound, it works. It can become a catalyst for adoption, and it can really improve, let's say, like a certain environment. Let's say you're building for, let's say, like you're building for like you're building a blockchain infrastructure for court systems. All right, now go to the courts and go into the government and try and convince people to come and use your stuff. Like, no way, no. It's like there's like no way that it's gonna fly. It's super bureaucratically gridlocked. There are many other incentives that you have not thought about. Incentives where like there are like many layers of people that in between the court system and your solution make a lot of money in between, and all of those people will also have to be incentivized and they have to benefit from it. So essentially what you're doing as a decentralized Web3 infrastructure, you're cutting out like 1,000 people, right? Now like I really like to make this analogy where you're saying like, all right, in a traditional system you pay somebody $100, right? Or let's say like the government awards an institution $100 to solve a certain problem. Now this institution goes out and hires an agency, and they will spend like $75 for the agency to tell them how they should spend that money. Then they get a report, and then they have $25 left, and then they will hire another agency to allocate that $25 correctly. And then that agency takes like 20, and then you take have 5 left, and then eventually like like some production company takes the $5, but then they go out and they go to China and they get another company to actually produce it, and they end up with one. It's like super diluted. So what you're essentially trying to do with a lot of Web3 infrastructure, especially when it's very utility driven, let's say like you're trying to build a court system and you're trying to build like settlement for disputes, like international disputes and so on. It's like you're cutting out like 1,000 businesses in between. So like, then tell me, how are you going to convince all these people to come and use your product?
Yeah, that's why I'm saying like it's difficult because traditional industries have their roots deeply set. So it's hard to sever all those roots at once. And convince people why they should sever those roots. But yeah, let's go back to Swarm. Because I did want to ask you what was the idea behind it, behind founding this, and I think maybe we could do like a small definition of AI agents, because people might not be familiar with the concept or differentiate an AI agent from traditional model they're chatting with them.
Yeah. So an AI agent, so agent, right? The word agent, like agent stands for agency, right? So it's an actor that has a certain type of agency, and agency basically means that can do certain things on its own behalf with its own, let's call it will, but it's not really will with an AI agent, but let's say directions, right? So there's a main directive, and the agent can decide. Of course, there are variables, there are constraints, but the agent can decide in respect to the goal, what am I going to do, right? So instead of giving a human a task, you say, hey, here's the company goal. By this quarter we need to make $200,000. You could do this with an agent, and the agent would understand the goal, and it would then be able to go out and use its tools to go and like whatever, transact, buy some stock, or it can essentially do what it wants. But there's a very clearly defined approach that it will take based off certain factors. So the first factor is like, how is it programmed? And the programming of an agent is interesting because you're using natural language. You're literally saying to the agent, like, you can do this and you can do that, and here's how I want you to behave, right? So here it becomes interesting because now all of a sudden we're not programming with code anymore. Of course, the underlying infrastructure is code, but we're using natural language to code, which is really cool. And then you have an action space. So you have your language package, and then you have an action space. And the action space, I'm using non-traditional terms for people that don't really understand it, because I'm talking to a lot of people and I'm using terms and they don't understand it. So I try to refrain from technical terms and try to make it, as easy to understand as possible. So an action space it's just a toolbox. Like if I am a carpenter, I have a hammer, I have a saw, I have glue, I have this and that. Like in a technical manner, like an agent also has this. It has a toolbox, and I can define that toolbox. So I can say, okay, I want my agent to be able to interface with GitHub, right? I want it to be able to create repositories and amend files and like pull requests and forks and what have you. And I want it to be able to access certain databases. And then eventually I also wanted to be able to probably like use the SUI network to transact. And I wanted to interface with like another protocol so it can buy whatever it wants, right? So, okay, this is the definition of what my agent is capable of. And now I have the direction, and then now I can start to, our CTO likes to call it like, give it a heartbeat. So now I can essentially set it up so it can keep on acting by itself and make decisions. So let's say, okay, like the pace is like every 15 minutes I run this thing, it starts to do something and it becomes more autonomous. But one major misconception is that, like people think like, oh, there's like this, you just turn on the agent and it just like continuously like, like keeps on going and does it like how you as a human would. Yeah. But that's really not the case yet. I mean, it's possible, but it's not really effective. So what is more effective is the combination of multiple agents into what we call a cluster. So we have, so now we go into the Swarm, if I may. If you're okay with that, I will go into, like explaining Swarm. So you can now take an agent and you can create a larger group of agents. And that larger group, again, is guided by a set of directives, again, in natural language. So I say like, okay, I have this agent, and this agent is responsible for task A. And then I have another agent, is task B, and task C, D, E, F, G, and so on. And all of those tasks, they are part of a subsystem. So let's say, let's put it into context. Let's say I want to create a cluster that is able to fact check a certain type of information on the internet, right? So I will have a agent that is defining the claims, like what should be fact checked. Then we have an agent that is defining an approach. And then we have an agent that is going to go out and source material. And then we have an agent that is analyzing the material, and then an agent that is probably, like doing some kind of like rational kind of like propagation of the information and putting it into perspective. And then we have a consortium of agents that is responsible for the consensus making. And then eventually the output of that whole system would be true or false, right? So that's a cluster. Now, a cluster can be a part of an even larger network, right? So you think, okay, I have a team of people, and the team is part of a company, right? So the same is true for the agents. I have a cluster of agents, but the agent can be part of a swarm, right? So the clusters can be part of a swarm, and that swarm can have a very certainly or a very specific job, right? Like a very specifically defined set of operational rules, but also desired outcomes. And then now whenever I send something into that swarm, it will activate like a network. You can think of it as like a map with different clusters that all have responsibilities, and it will pass information around. But instead of it being predefined, let's say it must always go through this route and then come back, it can do whatever it wants. That's the beauty about it, because the agents have a certain level of agency. They can decide by themselves who's supposed to do what. So what is interesting about this is that, okay, I'm going to say something a little bit controversial because it's actually not as grandiose as it is, I believe. But there's this notion of emergent reasoning and emergent patterns that form new types of capabilities for these agents when they're grouped in large networks, which is true if you consider, or if your like presupposition is that we will not be able to compute the random aspect of the routing. But I think that actually if you have a strong enough computer, you could probably generate quite accurate probabilities of how the problem is going to be solved, or all the paths that the problem could potentially go through to be solved. So to prove, okay, so swarm network, essentially what we do is we lower the barrier to entry for anybody that is not capable to code to create agents, clusters, and swarms, and then launch a swarm asset that allows these users collectively to govern the swarm. So I can group like 100 clusters together that belong to different users into a swarm that has a very specific kind of like end goal, right? And can really be anything. And I can launch an asset for that swarm, and I can use that asset for all types of things, right? So maybe I need to raise funds, or maybe I just want to use it for governance. So if you have a bunch of tokens, I have a bunch of tokens, we get to decide what the swarm is going to be working on, where it's plugged into, what the pricing would be for utilizing services, and so on. So it's a decentralized 360-degree lifecycle management for swarms, starting at agents, clusters, and then eventually swarms. But everything is done through no code, and natural language.
That's really nice. And I think these no-code solutions really help get adoption from, like, really grow the user base. So basically swarms are a decentralized brain, right? We can
Yes.
think of them as a decentralized brain. So would this multi-agent approach, is it more powerful or trustworthy than relying on one large centralized AI, for example?
Well, it is definitely more capable to do more complex things in a relatively safer manner. And why I say relatively safer manner is because we're partly making the stack transparent and making sure that things are on chain and so on. But in the end, you're still using the base models, right? So our users can decide what kind of models they use. So, you can choose to use a local model or an open source model, or you can still use like any other model, like whatever, OpenAI, for example. And I think the biggest danger lies within the base models, and that's a problem that we have to solve as a society. But it's definitely much more capable. So if you have a singular instance of an agent, it can only do so much. Like even with the great capabilities of the base models, the LLMs, and the super large context windows, you can only outfit your agent with a certain amount of capabilities. It's almost like a human, like there's no human in the world that can do every single thing. Usually people have a very specific, like set of skills, soft skills and hard skills. The same is true for agents. It's really hard to make an agent become really good at psychology and then also, whatever, like trading crypto. Like usually would want to try and limit the scope of an agent so it can be more focused and can equip more tools. But because those tools and the data that it can retrieve, but also the things that it can generate or the tools that it can use are more centered around a certain kind of like category or a certain type of skill, it's much easier for the agent to reason through the whole task essentially. And then additionally to that, the beauty about like larger systems is that an agent has a very local view, right? It doesn't have to have awareness of the entirety of the system, right? The system, at the top, there's probably like a knowledge base or some way to keep track of what's going on, right? Depending on what you create. Again, you can really literally almost create anything you want, but it's not important for a local agent to understand the whole. It just has to understand its own tasks. And then you have a cluster, and the cluster within the cluster, again, like agents can communicate with each other, but they don't have to communicate with the rest of the system. So that's how, like the outcome is bolstered, because instead of like the agent getting confused because it has too much, the scope is too broad, there's too many options. We now like define its roles and responsibilities really, really, really tightly, and therefore it can do a much better job.
Okay. It totally makes sense. And I think I read something about the economy for trust. You guys are focusing so fighting misinformation. Could you maybe tell us more about that?
Yeah, sure. So, where to start? Let's start with my personal motivation, shall we? So, I see a future that is very problematic because it's really hard for us to rely on our information systems like social media, like legacy media. I mean, like television. Nobody watches television anymore, but used to be television too. Now it's probably YouTube, right?
Yeah.
It's hard for us to trust these systems to accurately deliver us a ground truth that is, let's say, unanimously accepted by the entire world. And that's absolutely not the case. And it's really going to be very hard to achieve this. And you can see it right now, like the whole world is being polarized and put up against each other. And we're being torn apart from within because we're speaking the same language, but we cannot understand each other, because sometimes you speak to somebody that lives in a different vacuum of the internet where there's a different reality, and like you live in a different vacuum where it's a different reality, and that's all programmatic and engineered, and it might be on purpose, it might be a byproduct, but there's no way for us currently to try to find convergence and come closer to each other and find like a baseline truth. And the core issue of this is that we are not adequately fighting misinformation. And in most cases, large institutions, like media institutions, very powerful multi-billion-dollar institutions in the world, have been promoting a very strange thing, which is they're saying we are in the post-truth era, which means that like they think, or they are promoting that it's hard for us to have like a defined truth. They're just saying like, oh, truth is not that important anymore. Everything is a subjective experience. So it just depends on how you experience an event, and that is the truth for you. But that's flawed. That's false.
Which
because everything can be reduced to a almost mathematical like equation that can verify whether something is true or false, depending on the evidence and so on, right? So that was my personal motivation. I just think that this is one of the biggest issues in the world. And if you look at, if you look at statistics, 76% of the world population, that's an estimate, but it was polled, PwC, a very famous consulting agency that does these reports on a yearly basis. 76 of the Western world does not believe in journalism and institutions to tell them the truth anymore. They actually think that 76% of the people, right, as an estimate again, but they polled a lot of people, actually believe that they're being manipulated by media and that narratives are being spun to serve interest. Capitalistic interest is the argument, but I just think it's more political interest, not really capitalistic interest, because capitalism by itself is not an evil, is not a problem. But people are blaming it on capitalism, and they're starting to, saying now stuff like, oh, rich people are not good people and so on, but that's completely ridiculous. Anyway, to prove that our stack, our swarm technology works as we promote it, we decided to build out the very first swarm on top of our own protocol, which is called the Truth Swarm. And what it's able to do is it's able in real time on chain to verify any information that you throw at it. So of course, not every single piece of information can be verified in a conclusive manner. Sometimes a piece of information is something that is, a prediction of the future. But what our system is able to do is, if there's enough data available for it to be verified or falsified, it will do so. If not, it will give it a ratio based off the available data that it can find, like the entire swarm, and there's like thousands of agents tapped into different databases, not just searching the internet, but also tapped into private repositories of data and so on. It can give like a score, like a confidence score, and then eventually it's concluded, and the conclusion of a certain claim is then propagated and brought on chain. So effectively what we have is like a real-time on-chain arbitrary data verification system. You could call it an oracle, right? Because data on chain is like an oracle function. And what you can do with that data is amazing. I mean, like, you can do so many things. You can program smart contracts to, based off arbitrary data and based off claims, like perform certain tasks. So let's say I'm going to mention something really crazy, but if a nuclear bomb goes off, by as much Bitcoin as possible using my stable coins in this wallet, for example, right? You can now start to program these kinds of arbitrary situations into more rigid financial systems. Also things like prediction markets and so on. Like, we actually had a prediction market before, and one of the biggest issues was that it was really hard for us to bring on chain the conclusions of the market, because it was such a messy situation. And when are you right? When are you wrong? Like, you need a lot of people, you need like a jury. uma.xyz is trying to do this. But we realized that, all you need is like a bunch of agents that are as objective as possible, decentralized, distributed, owned by the community. So there's not like a single interest that is able to manipulate the system. And our stack would be perfect for that. So we built that. We're actually right now a official fact check provider for Google. The last 48 hours, we had more than 2 million requests on X. So how you can use the product is you can go to X and you can tag @rollup_news under any thread and add the word rollup, and you will receive an information rollup, which is essentially like a fact check version of that piece of information with all the claims propagated and then verified or falsified or scored, which is really cool. And we kind of went viral a little bit. So we actually had to shut down the servers like yesterday because it was too crazy, man. Like we blasted through like 2 pro plans on X, which are like 2 million credits each, and they wouldn't allow us to upgrade. So we had to figure out a different way. But yeah, so that's essentially like the first large scale swarm system that we built, and it's awesome, man. Like it's awesome.
This is a really cool use case because I see more and more in conversations on Twitter, people calling up AI agents to verify, to fact check different things, which is nice because see, you don't get to disagree in conversations anymore because you have the AI come and settle this for everyone. But
exactly,
you get conspirational people and people who have their own version of the truth. But again, this is due to large companies' interests.
And what is really but what is really interesting that you mentioned the other agents. So you can tag Rock, you can tag Perplexity, and you can tag a bunch of other things. But what they are doing is they're performing a search, right? A web search, and you get an instant answer. But a lot of the times, actually, I think still 75% of the time, like you will get a wrong answer or an answer that is relatively biased. But because our system employs like more than 1,000 agents, like the fact check that you get and the information propagation is done in such a way, which is it's much more accurate and it's much more objective. There's no strain of like subjectivity in the analysis and the verification. It's like as objective as we can get it at the moment. It's not perfect. I'm not saying it's perfect, but it's like way, 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 way better than just asking like an LLM that can do search to like verify a certain thing.
Let me know when you get back online because I want to use it as well.
Yeah, you can use it now. Like we didn't make an announcement that was back online because we have too many users at the moment. We have like around 87,000 users that are trying to use it every day. So we like slowly activated it again and people are using it again, and we didn't on purpose. We haven't made an announcement. Probably we'll make an announcement sooner or later. But I just wanted to make sure that people can actually still use it. Like we have like a core, like a hardcore user base, and I just wanted to make sure that they can use the product.
I'm excited. To be honest, I didn't know that you could use this. So I don't have time to read as much and do research as much as I would like to. Way too many cool things happening in this space.
Yeah, it's always crazy, man.
So how do you guys build privacy into your infrastructure?
Yeah, so
it is a privacy podcast. So I want to touch up on privacy a bit, if you don't mind.
Yeah, yeah, sure. Yeah, so we have a protocol which employs zero knowledge technology, and it's not available to the public, but it will be. That allows us to abstract away like sensitive information while still being able to verify it. So you can bring sensitive information to an agent or to a cluster or to a swarm without exposing that information to the wider public. And there are certain levels. There are certain levels to this, and there's different instances or situations where it's more important than others. But that's one of the ways that we are really trying to hone down on it, because we want to really make a point here with the truth swarm especially and the protocol itself, besides having an awesome product which people can use to build swarms with, right? Like what I want people to really be able to do is build swarms that are able to change something in the world and change it for the better. And there are so many situations where we need to use sensitive information to prove something or to perform an action, but there's no way that right now in the world we can make that information available in a efficient, private, but also, let's call it sensitive manner, right? Like if you hold information that is crucial for the world to know, but you cannot expose your identity because maybe, whatever, you'll be killed, or maybe you'll go to prison, or maybe, like you'll lose your job.
Yeah.
Then you should still be able to bring this information to the public in a safe and verified manner. So our ZK protocol is something which is really important to me. It takes a lot of time for us to develop this. It takes a lot of money too, and especially a lot of talent. So it's gonna be a while before we've fully integrated that side of the equation into the rest, but we will get there eventually. And then additionally, we don't touch user data. So we don't store data. We don't hold data. Everything that is on chain is essentially like just hashed and proof of work of the agents and outputs. But we still allow for the abstraction of private information to be just only handled locally by an agent and never be seen or touched by anybody else. And there's this really cool way where we can give an agent information and only the agent understands the information. Even we do not understand the information through a certain type of encryption, which is kind of like a new frontier in language models where we're experimenting with, let's say, new unique languages per agent that it's really hard to decipher and decode. And some of the agents that we're toying with right now, they reason in more than 12 languages at the same time, and they're using even made up languages to reason, but eventually they synthesize an output and they abstract and kind of like hide the information and the process away, which is novel and it doesn't always work, but this is something that we're experimenting with too.
You guys are great. I know you can't share the underlying technology, but did you take a look at other privacy solutions? FEG,
yeah,
like
I'm pretty bullish on TEs. Yeah, I'm pretty bullish on TEs, and we're actually we're experimenting with TEs. I don't know to what degree TEs are really a solution on the long term. And then there's obviously other stuff like trying to have our users to run everything locally, but then you still have the privacy concerns when you want to bring like a swarm or cluster at scale to serve a certain endpoint, right? Like you do need the consistency, you do need the reliability, and you do need kind of like the high throughput. So if you, let's say, if you put everything on the edge, it's not as efficient as it would be if you would probably like put it in TE as well. But then again, a TE still runs on a centralized server, right? So that's a problem.
I know. It does. And you still need to rely on the hardware manufacturer as well. I mean, trust hardware manufacturer. So yeah, there can be concerns.
But arguably, I would say that ultimately it's not. I mean, like, I think one of the flaws that a lot of us have is like we stick too much to a certain ideology, or ideological view of that is like that we kind of like, like we got from being in the blockchain space for a while, right? This ideological view of like everything has to be like 100% private, everything has to be like 100% abstracted, everything has to be 100% ZK, but is that really necessary to the extreme degree that everybody's trying to promote it? I don't
I
think
don't
so.
think so. No, me
I don't
neither.
think so. I think there's crucial things that have to be able to be more private, but not everything. You know, like, I mean, like, there's so much information out in the open. I mean, we can mirror our information systems in the real world, right? Our institutions and so on, and to what degree they have secrecy. And you can mirror that into the blockchain world, and then probably you can kind of imagine to what degree you really need privacy and abstraction. But there's a counter argument to that, which is that the problem is not us, but the problem will be AI, right? Like once you have that super intelligence and it has like literally the capacity to compute everything in the world all the time, like, okay, do you then need a safe way to like obscure and hide information away? Okay, probably, but are we going to get there? I'm not so sure.
You do need a lot of compute power to do that.
Yeah, but the quantum is the answer to that, no?
Yes, it should be, right? But the quantum could break everything as well, like all that compute power. You wouldn't get as much privacy as you as you would like, right?
Yeah. And also, you know what is fascinating about quantum is that it just fundamentally challenges like a lot of the beliefs that we have about things like consciousness, for example, right? Like how can you cannot explain quantum without consciousness, without explaining consciousness. Like if quantum makes sense, then probably a quantum information field has to make sense too, because it's not just pure, it really cannot just be pure randomness. You know, and the funny thing, a lot of people were not going to understand what I'm about to say, but in the world right now, we're trying to explain, like, we're trying to explain quantum physics and quantum mechanics with mathematics. But if the quantum field is real, and quantum field is an information field that is beyond our material world, then we could safely say that that is actually what created mathematics, and you cannot explain mathematics with that. It's the opposite way around.
Yeah.
It's very interesting topic. I know it's really hard. Yeah, it's super philosophical, but it puts it. I mean, like it puts it on the nose. It's like physicists nowadays will have to challenge the notion of consciousness and what it means in respect to quantum physics. And I think before that question is answered, we will not be truly able to harness the power of quantum mechanics and quantum computing.
Huh, that actually makes sense.
Yeah, because like, right, like hardware, a chip is like can be 1 or 0, right? That is the fundamental structure of our hardware. It's 1 or 0, but quantum is 1 and 0 at the same time. So how can you compute with this?
Yeah,
so
I've never thought of it that way.
Yeah.
I need to read up on that on that theory.
Yeah, there's this guy called Federico Fagin. He's Federico Fagin is actually the guy who invented the microchip. He literally invented the microchip.
I knew I heard that.
Yeah, and now he's trying to solve the quantum computing puzzle. And there's a few very interesting podcasts where he explains this whole situation. And if you listen to that podcast, I can guarantee you, like every 15 minutes, you'll be mind blown and you'll be like, whoa, whoa. And then you'll go down a rabbit hole trying to understand it. But yeah, it's a very interesting prospect.
I can see you went really, really, really deep down the rabbit hole.
Yeah, man. Like I actually picked up like a Roger Penrose book on the road to reality on all the equations and laws of the universe, because it just hooked me and I got really interested in it. I've never studied physics before, but It was
let,
just so
let me write that
fascinating to
down.
me.
Let me write that down. The road to reality.
Yeah, Roger Penrose.
I'll add it to my book list. One thing I forgot to ask you, I kind of skipped that while we were talking about the swarm.
Mhm.
How does consensus happen within the swarm? Like, what happens if an agent disagrees on a conclusion?
Yeah. So we haven't 100% settled on the, let's say, ultimate solution for this, but there's a few models that we are employing and that we are stress testing right now. So you have a fundamental problem in AI when we're talking about language endowed agents, because they're using something which is called a large language model. A large language model is trained on data, and that data is biased. There's no, like we as humans, we put so much shit out on the internet. So naturally, and the LLM is trained on like almost the entire internet. So you get all the trash and all the bad and the good, but it's just a mashup of all kinds of things. And then there are different training methods, and each training method yields slightly different results. No single large language model is the same. Each provider of these models trains on different data, structures the data differently, and thus you have a wide variety of different biases. And they're trying to fight those biases and curb the biases, but they're only curbed to the degree that is socially acceptable, but still there's still many black boxes within LLMs that we haven't opened yet. So when we're talking about agent consensus, this can become a problem, because an agent, if you build an agent, you might give it a direction and I give it a direction. And then like maybe you're trying to game the system. So you will say, like whenever we're talking about Donald Trump, this guy's a motherfucker, like say something negative and vote against, right? Like that's possible because it's natural language. So what we created is an underlying system. And this is really interesting because we had a prediction market before, which was wildly popular. So we had to shut it down. But the prediction market became still a very important aspect of consensus, because what we're toying with right now is, okay, what is a good way to make consensus? Well, you need to have safeguards against agents acting out of bad interest, right? So they need to have a stake. What is the best way to put up a stake is to make a prediction. So if I, as an agent or as a cluster, submit information for a certain outcome or participate in the consensus mechanism, I then now must vote, or I must vote on something, but my vote is actually a bet. And the more certain I am, the higher my bet would be, because the higher the upside there would be if the outcome of the consensus is potentially in my favor, right? So we're working with this like betting / market system, which is very rapid. It only exists for a very, very brief amount of time, several seconds, and it's hyper active. And it's not a prediction market about an event in the future, but it's a prediction market about the outcome of the consensus, whether all of the aggregated bets lean more towards 100 or 0. The more they lean towards 100, the more verified it is. The more they lean towards 0, the less verified or actually falsified it is. And we have different ratios. Those ratios are also not defined yet, but right now the ratio is if it's more than 76%, it's verified. If it's lower than 24%, it's falsified. And anything in between is up for debate and requires more information and more propagation. So that is how the consensus mechanism works. There are other models for this. There are also less dynamic, more pari-mutual solutions to this. And then we have another model, which is a stake-based model. So it's just you put up a stake, and whenever you are caught acting badly, you will be slashed. So there are like different consensus layers. There's an AI agent consensus layer, and then there's like an expert consensus layer, and then ultimately there's some governance on DAO level going on. But this becomes a very, very quickly this becomes a very complex governance system, and that those multiple layers for governance are also not necessarily required for most instances where we're just trying to, like, is this black? Like, we don't need the whole like 3 layers of governance. We can relatively easy to decide with a large amount of participants that this is indeed black. Yeah. So yeah, there are different models, and each model yields different results, and each model serves a different kind of situation better. I would say if you're dealing with very serious, let's say, accusations and information that can potentially like have great impact in the lives of people, then multiple layers of consensus are still required. Also, human oversight would still be required to a certain degree, but this should be a meritocratic system. This should not be a system where I just buy a bunch of tokens, and because I hold tokens, I can vote. That is the major issue with a lot of these protocols that are trying to solve, like the verification of data on chain, especially if we're talking about arbitrary data. Usually how it works is like I can buy a stake, and with that stake I can vote. But that doesn't mean that I'm not a bad actor, right? So we are employing a reputation system where over time I can establish myself to be an expert in a certain field. I can gain reputation, and off my reputation I gain reward. And it's more like a meritocratic kind of like voting and governance system than just plain token-based system. Because when we're talking about, let's say, a layer for trust of information, you cannot just deduce it into like a pure technical solution, because it's not a technical problem. It's a societal problem.
Yeah.
And a societal problem, you cannot dumb it down so much that it becomes a technical solution. It's not possible. It's impossible, because as you know, like wherever you go in the world, the further you go from home, the more different the world is. The more different people observe reality and propagate the information that they receive in different manners based off, like cultural values, societal values, institutional values. Like it's very different. Like, and there's no baseline for that. So it becomes a societal problem, and societal problems are only solved eventually through us as humans. So you still need some kind of like good actors within that network. Otherwise, it's a very dystopian, Orwellian kind of like solution almost, where you're like, okay, why don't we let the whole world be governed by AI agents then, right?
yeah, that wouldn't work. And I agree, like a proof of stake solution wouldn't work, because it would promote wealthy players to decide everything.
Yes, it's easily gamed indeed.
Yeah, it can be easily gained. I would like to move the discussion towards maybe, let's say, the intersection of blockchain and AI, if you're comfortable with that. I would have liked your take on a couple of things. So what's your perspective on blockchain, the importance of blockchain for AI? Do you think it enhances trust? Do you think scalability makes sense for agent-based systems?
Yeah. My perception of this is continually evolving. So probably what I'm going to tell you now is going to change in 3 months again. But there's a baseline to it, which is that I believe that blockchain is a more efficient technology for AI agents to operate than humans. So why? It's because, like the UI UX experience for blockchain is pretty clunky, man. It's like, it's like I need to make a wallet, I need to save my key phrase, I need to understand which network I'm on. I'm always at a risk of losing my funds if I make a mistake, like a small mistake, like I accidentally hit escape and remove like a digit of my my designated wallet address, or like if my computer breaks down, I'll probably lose access to my wallet, and I might have not saved the key phrase, but probably haven't. So there's a lot of risks involved, which are a blessing and a curse, but those risks are much better managed by AI agents because they are much less prone to making these kinds of mistakes, because to a certain degree they can be programmed, right? So then another thing is that the velocity of, let's say, like activity and exchange that can happen between AI agents is so great and so large that it's really hard to lose control. So if we allow these agents just purely to operate within our, let's say, our information environments, and use our banking systems and use our, traditional infrastructure, it's going to become really, really, really massive, messy, and like massive amounts of data have to flow through, and it will become unsustainable. So I think that Web3, and especially blockchain, is able to become somewhat of a infinitely scalable solution for that, because you can consider every agent a node within the system, and every agent could also contribute a certain degree to the compute of a whole network, although that's not really possible right now from technical perspective. But I see a future where if you run an agent, by default you're running a blockchain node, and that agent is also computing certain transactions, its own transactions, but also transactions of the agents that it's operating in vicinity with. And thus you have a more scalable system, which is always guaranteed to stay up, and you don't have to rely on centralized servers and like things that can easily break. For us to fully adopt that as humans, in the sense of like trying to capture the benefit of migrating all our systems to blockchain-based systems, it's very unrealistic, because we talked about this earlier, right? Like, go and convince your institution, your local bank, and so on, to go and adopt all this crazy new technology and cut out all of these people in the middle. Like, it's just not going to happen. But with AI, you don't have that issue. AI from the ground up can be built upon more secure, more scalable, more private infrastructure, which is blockchain, right? So it almost seems to me as if blockchain was actually created for AI, not for humans.
I love that thing. Blockchain was created for AI. Yeah, it's actually the perfect platform for AI, to be honest. And
Yeah.
I actually wanted to follow up with the question, because we did talk. I mean, the data you train the models is really important, of course. Let's take decentralized marketplaces like Ocean Protocol, for example. Do you see them tying into this, like being necessary for AI swarms?
Yeah, 100%. Like, there's no doubt about it. This also has to do a lot with kind of like the ownership, right? But also the availability of information, and also creating value for that information, right? So I see that there's a huge opportunity there, because like, one really interesting prospect for me is like, okay, how can we have information flow in a system that's accessible to everybody, but how can we make sure that the information has actually a value to it and becomes kind of like this economic driver behind like the capabilities of a whole network, essentially. So I think like these kinds of marketplaces are super, super essential, because that's how you create an economy. That's how you create, you establish a value for information. You establish a value for agents to be able to become a larger economical system and drive more how to say it, just like hold more value within the ecosystem, essentially.
Okay. Yeah, that's a really good thing. And what about GPU? Because AI is really hungry for GPU. Do you think decentralized networks can realistically support workloads for AI? Like workloads
Well,
at a large scale?
yeah, this brings us back to the issue of like what really has to be on chain, right? Can you put compute on chain, or can you put the settlement for that compute on chain, right?
Yeah,
Those are different things.
yeah.
Like those are different things. That's a misconception that I believe people. I mean, there's a lot of grifters out there in the crypto space, and they will tell you that they're doing on-chain compute, and I think that's absolutely baloney. That doesn't exist. Compute still happens off-chain, right? Like your GPU is like plugged into the wall, right? Like it's like the microchips in your GPU or in your CPU, whatever, are doing the work, and fundamentally that's not on chain. So the settlement for that work happens on chain. Can you scale that? Can edge compute scale from an economical perspective? Yes, sure. Is it important for the compute to be transparent? Yes. If you're talking about compute in sense of like informational, like propagation of information in the form of, for example, like an LLM, it's really crucial that that is transparent. So I think that on the long run, you'll see several things. First of all, the compute required to run complex systems is going to decrease over time because models are becoming more efficient. Models other than large language models trained in traditional manners are coming to market right now. You have like diffusion trained models, you have like image generation models, you have video generation models, you have computational models, you have like all sorts of different models, and now they're all going to be fine tuned, and like it's just the compute is gonna be the average requirement for compute to run a model, and the size of the models I think is gonna shrink. I think eventually, like this like smart pen is gonna have like a local AI chip that can just run like whatever, like 700K parameter model, and it will be able to do some crazy stuff. So I don't think that's going to be a huge issue. Probably the power consumption is going to be a common issue. It's like, how much power do we need to actually maintain such a large system across the globe? I think, I mean, like if you compare the power production rates of China to the United States, for example, we can already kind of like forecast that by 2030, probably the power consumption and the requirements for power on the AI front is not going to be sufficient. So there's going to have to be, like something that happens, like, I don't know, maybe go back to nuclear energy or something like that.
Nuclear,
so that we can.
I think that
Yeah.
I'm with the nuclear scenario.
Yeah, me too. So that's probably a bigger issue. And then, yeah, you can, I mean, like if we look at it that way, right? Let's say like compute is local. What has to be on chain is like the settlement for the compute, but also probably like the verification of the compute, whether it was truly done in a way that it was set to be done, probably through some kind of like ZK technology, or maybe more simply just hashing it like how you would do it on a TE. In that manner, yeah, it's definitely scalable. But then like you're gonna run into another problem, which is like, is the throughput going to be enough? And the answer here is no, not if you're thinking about like a single chain solution, but I don't believe in single chain solution. I actually think that like, for example, like the bit tensor model is really, it works well because you have all these like subnets, right? Subchains, which are chains that handle their own compute and handle like a throughput that is suitable for whatever information or whatever thing they're handling. So I think you're gonna have like a bunch of different networks, just like how the internet started. You had these like BBSs and modem dial-ups, and they were all different networks connected together, and there was some interoperability in between them. So I think this is gonna be the same for AI too. Probably you're gonna have like a big network that handles like transactions, a big network that handles like, maybe like, for example, like the truth protocol that we're building only handles, like fact checking of information. Then you have another protocol that handles like, I don't know, like video generation and compute for generative models, but probably only the settlement of that. And then you're gonna have another network that is gonna, like maybe Oasis is gonna handle like the privacy and this kind of stuff, like just a super
people
large.
yeah.
Yeah. And then all of a sudden becomes much more scalable, right? Because then I'm like, oh, what is my purpose? What do I need to do as an agent or as an end user? Okay, I need to interface with this network now, so I must adhere to its standards and interface with it. I take that information, bring it elsewhere. That's fine too, I believe.
Okay. Yeah. I think that would work. I was looking at the time, and we're way over the 1 hour mark. I try to keep the episodes around the 1 hour mark, not to bore the listeners. It's hard to pay attention for more than an hour, I found.
It's true.
But it's such a lovely discussion. I would go on for 2-3 hours now. Let's do a trend. What did you find exciting in 2025? Like, it's already, we're in May already. It's been an explosive year so far. What do you think is overhyped? What did you find exciting in the field of AI? And I want your take on humanoids as well.
Okay. Well, actually, I was gonna say I think robotics is just making leaps that nobody could have imagined. If you compare it, just look at Boston Dynamics, but also look at all the Chinese companies nowadays. Like the robotics, the capabilities of these robots, not really the humanoid robots yet, like as in like iRobot level, but like other types of like robots that do have autonomy too. It's just crazy, man. I just, like when I just saw that one video from Boston Dynamics where they're showcasing the flexibility and how that robot can move and fall and jump. Like if you compare it to a year ago, man, it's like miles and miles and miles apart. I actually was trying to figure out what was the big breakthrough that happened between like 1 year ago and now, because all of a sudden, all of the robotics companies seem to be producing and performing a lot better on like the flexibility and movability front. But also obviously they're starting to deploy different models for like cognitive, capabilities and autonomous decision making and so on. And I think that's a really nice prospect. I think that's really something that's gonna allow the world to progress really quickly once like they reach production stage and you have like a bunch of like robot nurses running around the hospital and like fixing the streets and like this kind of stuff. Like I think that's really cool, but at the same time it's also dystopian. It's like kind of scary. I've seen this robot, man. Like I've seen this robot, like it's like a Spot type of robot, but like Chinese one that can swim underwater for like a few hundred meters, goes out of the water, has like a rifle on its back and starts shooting shit. I'm like, whoa.
I have not seen
like,
did you
like
see it
they
in
can
person at like an expo or something?
No, I mean it was a video, but it's a real video. But yeah, like now those like dogs, they can fly and they can swim apparently.
Okay. Yeah, that is scary. I'll agree. I'll agree to that.
Yeah.
But I think it can be like the humanoid industry could be a very lucrative one. Like whenever this, I want to put some money into figure AI, into Aptronic. Whenever they go public.
Yes.
I think they have potential.
These are
quite a lot of potential.
Yeah. And here's where I also see some really interesting convergence for Web3. Like naturally you need more reliable, but also more autonomous, like systems. So I think that the prospect of paying your agent with like Bitcoin or Ethereum or USDT for a service is really cool. Like I would love to like buy a fleet of robots and then like rent them out, like just like rent them out to businesses and like allow the robots to, humanoid robots to take payments and then pay back to the network like a service fee or something like that. I think, these kind of prospects are just like, it's maybe hard to imagine for people right now, but I think that reality is much closer than you think. That's probably like half a decade out or something like that.
Yeah, depends on the actual production industry, right? we need to see how much they can scale it. As with every technology, you need to reduce costs at one point. But I'm really curious. This is 2025. Let's see where May 2030 takes us. Where we'll be in 5 years.
Well, I've seen a flying car, a real flying car.
I have not.
Yeah,
but
it's real now.
You're in Asia. Like Asia has a lot of cool technology.
Yeah. They had also these tests of the flying cars in the UAE a while ago, and here, around Hong Kong area, I've witnessed some events, and I was like, wait, like, am I in a dream? No,
I saw. Since we're talking about flying cars, I think I saw this on Jimmy Fallon. I think I don't remember. There was this company that was saying they invented a flying car, and this was in the US, I think. And they brought out people. They brought out reporters for a demonstration. But the car was like way off in the distance. You couldn't tell if it was a real car or nothing. It was, I think it was just a drone with
a drone with the car shape, right?
Yeah. And it was flying. That was funny. But it was like a real company. They went to a tech expo or something, and they were promoting their flying car. I don't know why we would do that. Besides
nowadays,
getting some funds.
Yeah, that's what I was going to say. Nowadays, you can sell dreams to venture capital.
Exactly. You can sell anything. Okay, last question, and then we can move on to the usual lightning round I do in the podcast. And this is regarding big tech, so the major AI players in the space. How do you see Web3 challenging their monopoly? Because we do need to challenge it, right? If we want better models and trustworthy models, we need to challenge that industry.
I'm not sure if I agree with this notion. It's almost like saying, like, does Web3 have to build a better internet, or does Web3 have to build a better Apple computer, or does Web3 have to build a better like GPU? I don't think so. I think we can see this. I think, like tokens, large language models and models, we can see them as kind of like a hardware driven, like, obviously it is, but a hardware driven software that doesn't have to become part of the blockchain stack. It doesn't have to be, because it doesn't make sense. What we need is accountability, and we need the world to come together, especially those that are building models, to make sure that there's a guarantee of safety. And I don't think that Web3 is going to be able to solve that problem. Web3 is going to be able to solve a plethora of problems that you get when you deploy these kinds of models into the real world and you allow them to different things, right? Like, as we've discussed, transaction, privacy of data, these kinds of things. But I don't think that we have to, as an industry, really challenge and build more or better models, because, to be honest, I don't think there's talent capable of doing so. And if there was, and if it was a really logical solution, then somebody would have already done it, I think.
Okay. Yeah, your point makes sense as well. I just always looked at the large companies being so decentralized. So I always I'm more of a dreamer that way. I think I'm not realistic if I think about it. So
I mean, the ideology of it is grounded in something that will benefit the world, the society, less centralization of systems and so on. But the funny thing is, like, once a model is built and I am allowed to deploy that model locally, let's say open source models, right? Like probably we should talk about open source models. Then, like the control is not really with the centralized, company anymore. So I think I'm a big advocate for open source, right? So like we should build more open source models for sure, because open source model, like open source, open weight. I mean, like there's a difference between open source and open weight. We also have to understand that. But let's say open source model available for, like deployment by anybody who wishes to deploy a model. And then also democratization and the probably commoditization of training large language models. I think it's probably we don't need like massive clusters of H100s in the future to train models. Probably we have open source models that we can fine tune just on smaller amounts of compute. So I think the decentralization is going to occur almost naturally, because it's really hard for a company to keep control of leading models, unless those models are like 1,000 or 2,000 times better than anything that is open source. But you can see that that's not really the case. Like all the companies, they're kind of like hitting the same benchmarks. Like whenever one company releases something, the other one releases, and the other one, it's like a race, and they're all matching up quite equally. So not really like massive edge. Like it's not like OpenAI has like a massive edge over XAI or over Meta or something like that. It's like they're relatively similar.
Yeah, I think even from a benchmark point of view, right? There's not a lot of difference nowadays.
Yeah.
I don't know. Do you see a model way better than other models suited for a specific task? Let's say Gemini and OpenAI's model and Claude.
I mean, there's differences between like the way the model feels. If you like speak to it, if you get outputs, and probably there's distinctive performance benefits for certain tasks when you use one model versus another. But they're not there. There's no like true superiority, I believe. And that's a really good sign. That's a really good sign. That means that
it's just a different approach.
Yeah,
I agree. For example, when I do research nowadays, I tend to use Gemini 2.5, the advanced research. I really like it. I really like that it's really professional with its research, how it structures everything, and I can fact check everything, go through the articles, it pull the information from, and verify everything, and really makes it easy.
And it has a really, really large context window too.
Yeah, I agree. Cool. Shall we move to the lightning round?
Let's do it.
Let's do it. So I have 6 questions for you, and I'll start off with the first one. And this is to describe AI swarms. AI swarms in one word: promise or peril.
Promise, of course.
Promise, right? This is an easy one. What's a Web3 myth you want to bust?
Oracles cannot be decentralized.
That's a funny one. Favorite sci-fi that influenced you? It may be a movie.
Star Wars. Star Wars.
God. You're a Star Wars guy. Okay.
Yes, I'm a Star Wars guy.
I'm a huge Star Wars geek. I have a huge Darth Vader in another room.
Since I was a kid, man, like Star Wars has been just like my go-to thing.
Yeah, it's been the same for me. When I'm down, I just grab a Star Wars episode or a movie, and I'm way better.
Yes, I feel you.
One emerging tech you're watching that's non-AI.
Ooh,
that's a difficult one.
Yeah. I mean, like robotics, but it's also AI, right? It's not fair.
Yeah.
Okay. I mean, like, EVs, electronic vehicles. EV.
Okay. Yeah. That's a cool one. Do you have an electric EV?
Yes, I do.
Which one?
I don't dare to say.
Why? It's the bad one. Do you have a Porsche?
No,
Do you have a...
no. But I'll be judged. I will not say.
Okay. I understand. Okay, I won't insist. Would you rather be governed by humans or autonomous agents in a dystopian future?
A dystopian or non-dystopian future?
Dystopian future.
Oh, that's a really hard one, man. Okay, I'm gonna cheat. I will give two answers.
Okay.
If we can establish a baseline truth that AI can operate on, like agents can operate on, then I choose agents. But if that's not possible, then probably I'll move somewhere in the world where there's like a small community without a dictatorship. That's like the final safe haven of humanity. I'll be there.
Okay.
No robots.
Okay. Answer accepted. Okay, I really like this last one. If your AI had a theme song, what would it be?
If my AI had what?
A theme song, like an intro to a show, a theme song.
Oh, Ghostbusters.
Ghostbusters.
Yeah.
That's a good pick. That's a good pick.
Ghostbusters.
Okay, this is the last question. Jesus, 1 hour and 30 minutes. Yeah, we could have gone for 3 hours easily.
Yes, definitely.
I actually let go of a lot of questions I had prepared, but
we should do a follow-up in like a few months.
We should do a follow-up, and maybe we can have other guests as well. Like I have episodes where I invite more people. So, but Marco really insisted that I have you on because he knew we would hit it off, and he was right.
Definitely.
But yeah, we should definitely do a follow-up. But thank you so much for joining, Yannick. It's really been a pleasure, and
thank you for having me.
I hope we can, as we said, we can do a follow-up episode soon. But yeah, this kind of wraps up the episode with Yannick from Swarm. Make sure you follow Yannick at Yannick Myson on X or Twitter. I don't like saying X. And check out. I really don't. I'll never get used to saying X. And of course, check out Swarm Network to explore what they have to offer. Don't use their. I mean, I'm not gonna publish the episode today, so the agent they have running on Twitter will be fully available when this episode goes out. But of course, if you enjoyed the conversation, make sure you follow Privacy Now on Spotify, on Apple Podcasts, on YouTube. I've got more Web3 pioneers coming your way soon.
Awesome.
And then until next time, stay curious, stay private, and never trust a single agent AI. Trust the swarm.
Yes. Thank you for having me. Appreciate it.
Thank you so much, Yannick. Bye, everyone.